Hello, my name is Katie Whiteside, and I will be presenting this module on dewatering activities. The learning objectives of this module are to understand what dewatering activities are authorized under the 2022 CGP, dewatering requirements for the authorized discharge, performing dewatering notifications, the dewatering SWP update that's required, dewatering BMPs, and dewatering monitoring and sampling. Authorized non-stormwater discharges in the 2022 CGP, they did add uncontaminated groundwater or spring water from construction dewatering activities to be allowed, and it's to be in compliance with Attachment J. This includes mechanical pumping or siphoning of non-potable water sources, including excavations and trenches, foundations, vaults being constructed, groundwater removal specifically related to construction activities, and/or water collected in impoundments, for example, ponds, puddles, low points on the active site, etc. One thing to note is that if you are working in an area that does have an area of special biological significance, that dewatering in these areas is prohibited unless covered by an exception by the State Water Board. Dewatering activities subject to or covered under a separate NPDES permit. It is the discharge's responsibility to determine whether or not the dewatering activities are subject to a separate NPDES permit. Also, the discharger may choose to apply for a separate NPDES permit for performing the dewatering activities. Dewatering activities not subject for coverage under another NPDES permit or prohibited, ASBS, for example, are subject to Attachment J of the 2022 CGP. Dewatering discharges are required to meet receiving water limitations and that they may not contain pollutants that threaten to cause pollution or a nuisance. Also, dewatering may not be performed in areas where known soil and/or groundwater contamination is present that could cause an exceedance of receiving water limitations. You can obtain information on known soil and/or groundwater contamination from GeoTracker, local permitting authorities, water boards, etc. One thing to note is that if you are performing dewatering and if your dewatering does exceed in a single sample concentration, the numeric, the NALs, then you must cease dewatering activities. There are dewatering notifications and SWP updates that are required prior to doing or performing a dewatering discharge. One is 24 hours prior to beginning of the dewatering discharge. You're to notify the regional water board's stormwater staff via email of the anticipated dewatering discharge. Also, the QSD is to update the SWP on site, and that SWP update is to be uploaded to SMARTS within 14 days. Within the SWP update, you are to include on-site BMPs for management of the dewatering discharge, what your cleaning and maintenance plan will be for dewatering devices and filter media used, your dewatering sampling protocols, and a site map showing dewatering activity discharge area locations. In other words, you're going to need to make sure that you have clearly defined on there where you're going to include or where you're going to perform the dewatering activities and discharge to. In the event you have an emergency dewatering activity that needs to occur, you are to notify the regional water board and the local MS4 system if you're discharging into an MS4 system within 24 hours of the discharge occurring. One thing to note is that an emergency is defined as the need to protect human life and health or prevent severe property damage. If you're not discharging under an emergency situation and you are planning to use an MS4 flood district or city storm or sewer conveyance system to discharge your dewatering discharge to, you may potentially need to obtain a permit or permission to utilize the storm or sewer conveyance infrastructure for discharge of the dewatering, and that you will need to make sure that you plan for the time it takes to obtain the permit or permission, as it may take anywhere up to between 30 to 60 days to obtain. Dewatering BMPs will be needed. The dewatering BMPs their goal is to be able to prevent dewatering discharges from contacting construction materials or equipment. Also, you are not allowed to use waters of the United States as part of the treatment area. Use energy dissipation devices. This way, you'll be able to prevent erosion or scouring. Examples of this can be check dams, sediment traps, riprap, grouted riprap, etc. If you're going to use a sediment basin or similar impoundments, it's wise to use outlet structures that withdraw water from the surface. That way you're avoiding stirring up more sediments and discharging clean water. Monitoring and sampling is required. Visual inspections, monitoring, and sampling of dewatering discharges are required. The dewatering discharge is to be sampled within the first hour of discharge and daily for continuous dewatering discharges. There are sampling requirements, and the sampling are required to be met, and the required sampling are for pH and turbidity, and that you must comply with NALs. The sampling results that are obtained are to be submitted in the annual report. If sample levels exceed either of the NALs which are for pH and turbidity, the following actions are to be taken. The dewatering activities are required to cease until dewatering meets NAL requirements. The results of the NAL exceedances shall be submitted through SMARTS within 10 days of sampling, and the QSD shall revise the SWIP with immediate corrective actions to prevent further exceedances within 10 days of the exceedance. One exception, again, for ceasing discharge is only in the event of an emergency to protect human life and health or prevent severe property damage. Summary of key points are: 1, make sure that prior to performing a dewatering discharge, that you notify the Regional Water Board within 24 hours of the discharge. SWIP is to be updated by the QSD with dewatering information, and that information, again, is to include BMPs, your sampling maintenance requirements, the location of discharge, etc. You're required to implement BMPs to control the volume and velocity of dewatering discharges, filter and treat dewatering prior to discharge as needed, and that there are sampling requirements for pH and turbidity. Again, this is for these requirements in this module are covered for projects that are under the 2022 CGP for dewatering and that are not subject to a separate NPDES permit, such as de minimis and low thread discharges. Thank you. This concludes the module on dewatering.
Hello, my name is John Heltzel, and I will be presenting this module on passive treatment technologies. So first off, just want to provide an overview of what this module will be covering. First off, we will dive into how passive treatment is defined. Next, we'll talk a little bit about design and toxicology. And then towards the end of the presentation, we'll discuss application, monitoring, and reporting for passive treatment technologies. And so first off, passive treatment, as it is described in attachment G of the 2022 CGP, is the application of natural or synthetic chemicals and products to reduce turbidity and discharges through coagulation and flocculation. Passive treatment does not rely on computerized enclosed systems with pumps, filters, and real-time controls. This second part of the definition is particularly important, trying to draw a delineation between passive and active treatment systems, where active treatment would have those real-time controls and the ability to monitor those controls with computers. And so here I have two photographs that just show potential components of a passive treatment system. On the left, you'll see a channel that is lined. There are several blocks of passive treatment chemical that can be seen in the bottom of the photo. There is downstream from that some jute matting, and essentially stormwater flows would pass through that channel. Some of the passive treatment chemical would then dissolve from those blocks and cause sediment particles to bind to the jute matting and then continue to flow through that channel. On the right, we have a sedimentation basin, and often those in-channel setups would then flow to a sediment BMP, such as a sedimentation basin, just allowing for those sediment particles to again settle out and be removed from that stormwater prior to discharge. So just a few examples of what a passive treatment system may look like. Moving along further with the definition, attachment G specifically applies to the use of passive treatment products that remove suspended solids such as sediment from stormwater. And so the application of those technologies can look a little bit different, but the primary examples are liquid treatment chemicals, powders, or slow releasing solid blocks, as you saw in the photo on the previous slide. Again, without using an active treatment system. Another just item to highlight is that application of these products is specifically prohibited in attachment G to receiving waters. And I believe I'll mention that again as well later in the presentation. So a few general considerations when discussing passive treatment technologies. One of the main points to highlight is that passive treatment should not be used as a standalone BMP. So it's really important on a construction site to first maximize the use of traditional erosion and sediment control practices, ensuring that you have appropriate erosion control and sediment control in place first, using those traditional practices before looking at a potential chemical treatment option. Also, it's essential that toxicity information is available for any passive treatment chemicals that are used on a construction site. Both the acute as well as the chronic toxicity information should be available for those chemicals. And how those chemicals are applied and stored, it's important to ensure that secondary containment is used and that application practices minimize any potential for an accidental discharge. The goal being, again, to protect water quality and avoid any accidental discharges on your construction site. Moving along to design and toxicology requirements. The use of cationic chemicals is not allowed under attachment G in the 2022 CGP in a passive treatment application. However, anionic polyacrylamides are authorized for use as long as they meet some of the following criteria. So some of those criteria include a charge density between 10 and 55% by weight, having a high molecular weight, preferably between 6 and 25 megagrams per mole, and then also be food grade. And in all circumstances, when these passive treatment chemicals are applied, it's important to ensure that the manufacturer's recommendations are followed, because depending on the chemical, that may change from site to site. And so that communication is important when designing and implementing these passive treatment systems. So also with respect to the design, a California licensed professional engineer shall design the discharge locations from any location with passive treatment products being used to dissipate energy from any concentrated flows. And really the goal there is to try to provide additional opportunity for sediment to settle out after it's been bound with the treatment chemical, and also to prevent any potential discharge of unbound chemical from a construction site. Also, it's important that any stormwater treated with these products in a treatment zone before it's discharged from the site shall pass through a sediment control BMP, such as a sedimentation basin, as I showed on my second slide. And again, there, the goal is to really provide an opportunity for sediment to settle out of the stormwater. And also, if there is any unbound chemical, provide an opportunity for that to settle out as well and not leave the discharge or not leave the construction site. Additional application requirements. So the application rates of the chemical dosing and methods for application, again, should be determined based on the manufacturer's guidance. Another really critical aspect is to perform site-specific testing to ensure that an appropriate product is matched to the soil type on your construction site. And now what that is going to do is just maximize the overall efficiency of your passive treatment system. So particular chemicals will perform at their best with certain soil types. And typically a jar test is used to try and identify the best chemical product to be used. And again, what that'll do is allow for the most sediment to be bound and settle out, while also using the least amount of chemical on that site, which again protects water quality and limits the possibility of accidentally discharging unbound chemical from the construction site. So site-specific soil testing is an essential step early on in this process. Again, applying these products directly to a receiving water is prohibited, and the discharger shall employ a trained person just to ensure that the mixing and reaction time suggested by the manufacturer is followed during application. Now, this is listed in the application section of attachment G in the 2022 CGP. But I think this is also something that needs to be considered early on in the design stage of these systems, just to ensure that the appropriate design is met. And then again, during application and when these systems are functioning, to verify that they are functioning as designed. So some monitoring requirements. There is the requirement to complete a passive treatment plan. And that's going to be, that document is to be prepared by the QSD for a particular construction site. And I have here a list of components included within that plan. And so we'd have a list of all the erosion and sediment control BMPs implemented within the drainage area. Again, the toxicity information from the manufacturer would be a critical component of that plan as well. Contact information for the PE that designed the discharge location, QSD, QSP, as well as any other practitioners involved in the application. Any inspection and maintenance requirements. And this is really an important one, that these sites or systems are monitored, and that they receive the necessary maintenance between storm events, and any adjustments that need to be made in between storms may also be required. Any relevant spill prevention and response procedures should be included. and then calculated and recalculated quantities of passive treatment products used. The recalculation is also a critical component. In some instances, for example, those blocks that I provided a photo of, they may release treatment chemical at different rates depending on temperature, pH of the water. And so ensuring that your dosage is, your calculated dosage is the true dosage in your system is a critical component. And then lastly, treatment zone soil types, as well as any application dates and methods should also be included within that plan. With respect to reporting requirements, so before any passive treatment chemicals are used on a site, the passive treatment plan should be submitted through SMARTS at least 14 days in advance. And there's also an application checklist that should also be kept with that plan. There's additional details in section D4 that you can reference. And along with keeping the SWP updated, that passive treatment plan should also be updated with any relevant information, and that plan should also be kept with the SWP. Application requirements continued. Again, this is an item that's listed in the application section of attachment G, but it is also, I believe, should be considered during the design phase. So the discharger shall ensure that the appropriate settling area for the passive treatment product, sediment-laden stormwater, is sized to hold sediment and allow for reasonable cleanout frequencies. So again, that kind of comes back to the design phase. And if any assumptions made during the design phase prove to be inaccurate after the first storm event or any later storm events, then changes may need to occur, such as additional space or settling area, or increased cleanout frequencies, just to make sure that your BMPs are functioning appropriately. All right, and lastly, just a summary of key points. Again, passive treatment chemicals should not be used as a standalone BMP. It's important to maximize the use of traditional BMPs. Site-specific soil testing is required to match soil type. At all times, the manufacturer's application guidance should be followed. Passive treatment chemicals are not allowed. Cationic passive treatment chemicals are not allowed for use under attachment G. And thank you. This concludes module 11 on passive treatment technologies.
Hello, my name is Matt Hromadka, and I am presenting on attachment F of the Construction General Permit, Active Treatment Systems. So what we're going to be going over today is what an active treatment system is and what has changed between the 2009 permit and the 2022 permit. Okay, so what is an active treatment system? An active treatment system is a series of pumps, filters, treatment controls, probes, computerized recording that is deployed to construction sites to control turbidity and pH. Okay, so what has changed between the 2009 permit and the 2022 permit? So what has changed is there is now a bypass allowance. There is now pH NEL has been added. And in addition to pH, turbidity, flow, the things that we have previously been reading and recording, there is now a freeboard on storage requirement that is to be read and recorded and submitted to SMARTS every 30 days. And so what that means is that your basins, tanks, storage devices, whatever that may be, the freeboard in those basins or storage devices is to be recorded every 15 minutes and reported along with turbidity, flow, pH. And then what has not changed? The ATS manager criteria has not changed. The turbidity and the residual chemical NELs have not changed. We've just added the pH NEL. And then, like we talked about, the turbidity, flow, pH, all those minimum recording parameters remain the same. We've just added the freeboard parameter. And then what else has changed? Operator training requirements have been eliminated. So we used to have 40-hour specific 40-hour training requirements to operate the ATS. And so that has been eliminated. And then the remote operation of the ATS allowance has been added to the permit. We'll talk about that some more. And then what has not changed is the residual chemical sensitivity and the turnaround times for the residual test has not changed for a flow through system. And then for the batch treatment system, the bioassay requirements stay the same. Okay, so the bypass allowance. So the 2009 permit did not have any allowance for a bypass, and all water had to be processed through the ATS. So in the 22 permit, the ATS may be bypassed if the basin, the pond, is meeting all of the permit requirements, as well as attachment F, the NELs, NALs, and all attachment D and E. And then if you have dewatering that's occurring that is part of the bypass, then you have to also meet attachment J. What has changed? The pH NEL. So the 2009 attachment F did not have a specific pH NEL, and now we do 6 to 9. What has changed? The minimum recording freeboard. So we talked a little bit about this, but the 2009 permit did not require, how much storage was available in your tank or basin, where the 22 permit does require it, and read and recorded along with everything, all the other requirements, and recorded submitted every day, every 30 days to SMARTS. And it's important to note that if there is an NEL violation, that the NEL violation report must be filed within 14 days of discovery of the violation. And then the operator training requirements, as we talked about, the 40-hour training that was in the 2009 permit is no longer required by the 2022 permit. Remote operation allowance. So there was no parameter available in the 2009 permit to allow remote operation. The designated person had to be on site the entire time the system was discharging. So the 22 permit allows for a remote operation. You can have a designated person on site. So much like 2009, you can still have that person on site and observe the ATS portions. However, you can also have an operator monitoring the system from offsite with specific requirements for the system shutdowns and safeguards. So in summary, a bypass allowance has been introduced. All the water must be in compliance with the NALs, NELs, and receiving water limitations. ATS operators no longer require the training, 4-hour specific training. Remote operations are allowed with very specific requirements. And there is now NEL for pH included in attachment F. And the data collection and reporting of freeboard for the pond, tank, your basin system is now required to be read and recorded and reported every 30 days. And that concludes the presentation for attachment F of the construction general permit active treatment systems. Thank you.
Hello, my name is Shawnetta Granberry, and I will be presenting this module on demolition activities covered by the 2022 Construction General Permit. The learning objectives for this module are to understand how demolition activities impact water quality, evaluate the pollutants of concern associated with demolition, and to summarize the B&P requirements for demolition projects. So what is demolition? Demolition and pre-development site preparation includes demolition of existing structures, exposure of underlying soils, rough grading, clearing, or any soil disturbance that occurs prior to mass grading. So how is this all applicable to the 2022 Construction General Permit? Construction projects that disturb more than 1 acre of land are required to apply for a Construction General Permit. Projects that require the demolition of buildings, parking lots, and other structures in association with land disturbance are required to seek coverage under the Construction General Permit. Now let's talk about some of the pollutants of concern associated with demolition projects. The most common pollutants associated with demolition projects include trash, sediment, oil and grease, asphalt, glass, concrete, paint, heavy metals, wood, plastic, and hazardous materials. Many of these pollutants are detrimental to water quality when they are not disposed of properly or stored improperly. Hazardous waste are waste materials that are potentially dangerous or harmful to human health and the environment. Hazardous waste can be liquids, solids, or gases. They can be the byproducts of construction activities or discarded products such as cleaning fluids, solvents, and pesticides. There are 3 hazardous waste regulations used in California. The first being federal waste regulations adopted by EPA. Second are regulations adopted by the California Department of Toxic Substances Control, or DTSC. And third are the regulations adopted by the Regional Water Quality Control Board. The DTSC defines waste as hazardous or non-hazardous, simple enough, but the regional board further defines waste into 4 distinct categories: hazardous, designated, non-hazardous solids, and inert. Once the materials have been identified, the appropriate containment classification must be implemented to protect human health and the environment. The QSD may need to include additional B&Ps in the SWPPP to decrease exposure and the potential for discharges. Let's take a moment to talk about how the Regional Water Quality Control Board defines hazardous and non-hazardous waste. The first category includes inert waste. Inert waste is waste which is neither chemically nor biologically reactive and usually doesn't decompose. This category consists entirely of non-water soluble and non-decomposable inert solids, like uncontaminated soil, rock, concrete rubble, and asphalt grindings. The next category of pollutants are non-hazardous solid waste. These consist of decayable and non-decayable solid or semi-solid waste. These types of waste are not necessarily hazardous, nor do they contain soluble pollutants in concentrations that exceed water quality objectives. Non-hazardous solid waste have a low potential to degrade designated waters of the U.S. Most common types of non-hazardous waste include trash, garbage, abandoned vehicles and parts, and discarded appliances. Designated wastes are a type of non-hazardous waste which requires special disposal variances such as recycling or pretreatment. Designated wastes have the potential to contaminate the environment and may only be disposed of at Class II disposal sites. Although not necessarily hazardous when handled and disposed of properly, designated waste materials still have the potential to release pollutant concentrations that exceed water quality objectives. Common types of designated waste are food waste, paper, plastic, metal, and glass. Although demolition and construction debris are often included in collected waste, they sometimes contain small quantities of hazardous materials such as electric light bulbs, batteries, discarded medicines, and chemicals. Simply defined, a hazardous waste has properties that make it dangerous and capable of having an adverse effect on human health or the environment. Hazardous waste can be generated from a variety of sources and activities that occur on construction sites. They may come in the form of liquids, solids, gases, and sludges. Regardless of the physical state, hazardous waste will always exhibit at least one of four characteristics. They can be ignitable, corrosive, reactive, and even toxic. There are four common hazardous waste materials that you may encounter during demolition. The first being asbestos. During demolition, projects containing asbestos usually have a higher fiber strength and higher heat resistance. Prior to 1977, asbestos was commonly used in building and construction materials and in a variety of manufactured goods. Asbestos can be found in roofing shingles, ceiling tiles, paper products, cement, automotive parts, packaging, and coatings. The areas designated for demolition should be tested for asbestos, especially for structures that existed prior to 1977. The second most common hazardous material are devices containing mercury. Mercury can be persistent and toxic to the human environment and to health. Mercury-containing devices such as thermostats and fluorescent lamps should be isolated, removed, and taken to an appropriate disposal facility. Lead-based paint is often found in older structure and has a higher likelihood of being encountered during demolition activities. Lead-based paint can be mobilized and behave a lot like dust. It can be inhaled by workers and even tracked off-site, causing hazardous exposure to the community. Lastly, polychlorinated biphenyl, or PCBs, have been identified in many older structures. Protected BMPs and OSHA-approved personal protective equipment must be utilized to prevent exposure of PCBs to workers and the surrounding environments during and after demolition. If the construction site is located in an area where a TMDL has been designated, the project must be compliant with all PCB TMDLs, mercury TMDLs, and statewide policies. Dischargers are required to schedule demolition activities during times with the lowest probability of precipitation. Demolished materials must be covered when the activity stops for the day and prior to a rain event. The QSP or QSP designee should examine the demolished materials for hazardous waste and implement BMPs that prevent materials from discharging off-site. When preparing the SWPPP and implementing BMP requirements, the QSD and QSP must remember that PCBs were commonly used between 1950 and 1980. They should be considered potentially present in structures during that time. The 2022 CGP SWPPP development guidelines include a new requirement for a pre-earthwork drawing that shows areas slated for demolition. Pay special attention to ensure that demolition materials are not exposed during rain events. Make sure to cover demolished materials with impermeable barriers, such as plastic sheeting, prior to a precipitation event. QSPs and QSP designees must sample for non-visible pollutants if demolition materials are left uncovered. Lastly, make sure the site complies with TMDL requirements found in Attachment H of the Construction General Permit. For more information about demolition projects and hazardous materials, please visit the US EPA website. We have included a link here. There are also many other great resources available online. Thank you. This concludes the module on demolition activities.